So let's inject some shellcode into another process. So open up code injection, shellcode, and let's take a look at the source code. So this program is a little bit more complicated, but not too much. So the main function is pretty simple. Basically, what we're going to do is we will be injecting this shellcode, which is a message box, shellcode 64-bit version. And the reason is that it's a message box and not something else is that the first thing is we are injecting into the GUI program, notepad.exe, and what I want to do is to show you that the code was actually injected and executed from Notepad. Okay, so first we call findTarget function, which basically what it does, it takes the name of the process we want to inject to, and it tries to find it in the memory of the operating system. And if it exists, it is running, it will return a process ID of that process. Okay. So if it's successful, we open up this process. We get in return, we get the handle to the process, to notepad.exe, and we call inject function with the handle to notepad and our payload. FindTarget function works like this. We take this snapshot, so we call create tool help 32 snapshot function, which basically takes the snapshot of all the processes of running in memory of the operating system. And then we use two functions, process32 first and process32 next functions, which will go through the snapshot and extract all the information about the processes from that snapshot. And in this loop, we are just taking these records one by one and compare it with a process name, which is notepad.exe. And we ignore, with this function, we ignore the capitalization of the process name. And if it's found, then we extract the process ID, we save it in this variable, and then we return it back to main. Inject works pretty similar to what we've been using so far, but this time we are using these three functions I've mentioned in a previous section. So it's going to be using VirtualAllocEx, which will allocate a memory buffer in a remote process, which is pointed by this handle. Okay, we get the address of that buffer in remote code, p remote code variable. Then we write our payload into this remote buffer, and then we create remote thread in this remote process, pointing to our remote buffer, and that's pretty much it. So let's compile this program. So RTO code injection and to shellcode. So let's run a compile. Okay. And implant, you can run it, but before we run it, we need to run notepad. Okay. So let's execute it. The process ID of notepad is 816. And we can see that there is something popped up from here, which is actually our payload. But to prove it that it was actually running from Notepad, let's launch our process hacker. And first of all, we can see that ID of the Notepad is the same as found by our dropper, by our implant. But how to prove that it was actually launched from Notepad? So Process Hacker has really nice function here. Find window and thread. You left click and hold, and then you point to a window you want to investigate. So in this case, it's going to be message box. We release, and Process Hacker will show you, will open up a process which actually this window or this pop-up belongs to. So in this case, it's our Notepad, which is 816 ID, and this particular thread is actually running this message box. Now we need to we can even dig in further. So we go to memory tab, and we can look for the memory buffer we allocated, because if you take a look into the source code, we are allocating some executable and readable memory buffer in a remote process. So in a process hacker, we can search for sort by protection and scroll down and find a region which is readable and executable at the same time. And there is a lot of such regions in the memory of Notepad, but only one is not mapped. That doesn't have a mapped file from disk. So all other regions have some PE file backed, are backed by some PE file from disk, but this one is not. So we can open up it, and you can see our shellcode. Okay, so we can see hi from red team operator, which corresponds to this message. Okay, and you can even compare it with a source code FC4881, etc., etc. So this is how you can inject your code into another process.